Hey, future CU toppers, and welcome. If you're gunning for that top percentile, you already know some chapters are just guaranteed marks. And alcohols, phenols, and ethers, that's one of them. Today, we are going to absolutely master the foundation, how to name and classify alcohols. And look, this isn't just boring theory. We're talking direct MCQs, assertion reason questions, stuff that can easily grab you 4 to 8 marks. If you get this right, you're building a rock-solid score. So stick with me, because we're about to lock in these concepts for good. Okay, let's jump right in with a little challenge. Take a look at this question on your screen. This is a classic high-yield CUET problem. It mixes classification with physical properties. Now, if you're feeling even a little bit hesitant or you're not 100% sure of the answer and the reason why, that's totally fine. Because by the end of this short explainer, you'll be solving questions just like this in seconds. I promise.
So here's our game plan. We're going to start with the fundamental IUPAC naming rules, the basic language of organic chemistry. Then we'll nail the super important concept of classifying alcohols into primary, secondary, and tertiary. After that, we'll circle back and completely demolish that boiling point question, and then we'll wrap up with a quick exam drill to make sure all this information is fused into your brain for good.
Right, first things first, before you can classify anything or compare anything or predict any reactions, you have got to be able to name the compound correctly. Mastering the IUPAC code isn't just a suggestion. For CUET, it is completely non-negotiable. So let's lock this skill in right now. So, what even is an alcohol at its core? It's actually really simple. You're just looking for an organic compound that has one or more of these hydroxyl groups. That's the OH. And it has to be attached to a saturated carbon atom. That just means a carbon with only single bonds. That little OH group, that's the functional group. It's the star of the show. It decides the compound's name, its properties, how it reacts, basically everything. Now, these 4 rules right here, they're your key to unlocking pretty much any naming question. Just follow them in order every single time. But I want you to laser focus on rule number 2. Giving the OH group the lowest possible number, this is a classic CUET trap. They'll give you a structure where maybe numbering from one side gives a different group a low number, but you have to ignore that. You always prioritize the OH group. It gets the lowest number, period. And this slide right here perfectly illustrates that point. Just look at propanol versus propanol 2-ol. It's the same 3-carbon chain, right? But where that OH group is located changes the name completely. In propanol 1-ol, the OH is on carbon 1. In propanol 2-ol, it's on carbon 2. It's all about giving that OH the lowest possible address on the chain. Okay, this is a really crucial point for competitive exams. The OH group isn't always the main character. If you've got a higher priority group like a carboxylic acid hanging out in the same molecule, our alcohol group actually gets demoted. It becomes just a substituent. And when that happens, we call it hydroxy. You have to know which groups outrank alcohols. This is a really common way they mix up concepts in the exam.
All right, so now that we can name them, let's move on to how we classify them. And let me tell you, this is arguably one of the most frequently tested concepts from this entire chapter. Examiners love to ask you to identify if an alcohol is primary, secondary, or tertiary, because that directly affects how it reacts chemically, which is something you'll definitely study later.
First, let's get the easy classification out of the way. You can just group alcohols based on how many OH groups they have. If there's 1, it's monohydric, like ethanol. 2 groups, it's dihydric. 3 groups, trihydric. Super simple identification, super easy marks. But now for the big one, the classification that CUET examiners are absolutely obsessed with. This is all about the nature of the specific carbon atom that is holding on to that OH group. This is where we get the terms primary, secondary, and tertiary. So you're going to want to pay close attention here. A primary alcohol, and we write that as 1 degree, is where the carbon atom that's bonded to the OH group is attached to only one other carbon atom. The key word here is 1, just 1. Think back to our propan 1-ol example. The carbon holding the OH is only attached to one other carbon chain. That's what makes it primary. And following that same logic, a secondary or 2-degree alcohol is when that special carbon, the one with the OH, is directly attached to 2 other alkyl groups. You see the pattern, right? The name literally tells you what to look for. Propan 2-ol is the perfect example of a secondary alcohol. And finally, we've got tertiary, or 3-degree alcohols. And you probably guessed it, this is where the carbon holding the OH group is bonded to 3 other alkyl groups. So here's your foolproof strategy for any question like this. Step 1, find the OH group. Step 2, look at the carbon it's attached to. Step 3, count how many other carbons are directly bonded to that carbon, 1, 2, or 3. And that's your answer, primary, secondary, or tertiary. Simple. Okay, so remember that question from the very beginning? Now we have all the tools we need to completely solve it. This is a very, very common question type where they give you isomeric alcohols. Remember, same formula, different structures, and they ask you to arrange them by boiling point. This is a perfect test of your understanding of how structure affects physical properties. So the most crucial thing to remember is this trend right here. For isomeric alcohols, the boiling point goes down as the branching goes up. That means primary alcohols have the highest boiling point, then secondary, and tertiary alcohols have the lowest. Here's a quick memory trick. The trend decreases in the order PST. Just think PST for primary, secondary, tertiary. Go ahead and write that down. Boiling point order is P is greater than S is greater than T. So why does this happen? Well, it's all about intermolecular forces. A primary alcohol is a pretty straight chain, which gives it a large surface area for other molecules to stick to. But a tertiary alcohol is highly branched. It's more like a sphere. This compact shape means less surface area, which leads to weaker van der Waals forces between the molecules. And if the forces are weaker, you need less energy to pull them apart, which means a lower boiling point. It just makes sense. All right, theory is done. Now it's time to put your knowledge to the test with a quick exam-style drill. This is where we really see if you've got it down. Ready? Let's see if you've been paying attention. Here's your question. What's the correct classification for 2-methylpropan-2-ol? Is it primary, secondary, tertiary, or dihydric? Use that foolproof strategy we just talked about. Find the OH, find its carbon, and count its neighbors. I want you to pause this explainer right now. Seriously, work it out, maybe on a piece of paper, and commit to an answer. No peeking. Go on, hit pause. And we're back. The correct answer is C, tertiary. So why is that? Well, the central carbon atom is holding on to the OH group, and that same carbon is directly bonded to 3 other methyl groups. That makes it tertiary. And of course, it's not dihydric because it only has 1 OH group. See? Simple. Now let's go back to our very first question. Propan-1-ol is primary. Propan-2-ol is secondary. 2-methylpropan-2-ol is tertiary. And since the boiling point order is P greater than S greater than T, the correct increasing order is tertiary is less than secondary is less than primary. You just solved a guaranteed CUET question. Before we wrap up, let's do a quick rapid-fire revision. This slide right here is your ultimate summary. Go ahead, take a screenshot of this right now. It's perfect for that last-minute revision. Let's go. Monohydric, 1 OH. Primary, the OH carbon is attached to 1 other carbon. Secondary, OH carbon attached to 2 other carbons. And tertiary, OH carbon attached to 3 other carbons. And the boiling point trend? Primary is greater than secondary is greater than tertiary. Got it? Awesome. So you've totally cracked the basics of alcohol classification and their boiling points. But here's a final thought to really level up your prep. How do these boiling points compare to, say, alkanes or aldehydes with a similar mass? What's the special intermolecular force in alcohols that makes them different? Chew on that because it's a concept that ties multiple chapters together. So how did you do on that practice question? Let me know in the comments below. If you found this useful and you're serious about acing CUET, make sure you subscribe and join our community of future toppers. Keep studying hard, and I'll see you in the next explainer.